G'day viewers, I decided to take the running components intact out of this fridge. Although it is an interesting fridge, it's not as crappily built as a cheap Chinese junk you buy today, but it's made to the same standard. Cardboard and cheap plastic, thin metal, but I might just glue that cut bit back in there and make a box to store wood in out of it. I needed another box to store wood in, so that's what I'm going to turn this into. But I took the running gear out of it intact. I used a Sawzall, but I very slightly, and I do mean slightly, and nicked the pipe because it was rattling. And I was having it on this side, but I slipped with the saw and I cut a tiny little bit of nick in here. I didn't cut it all the way through, but I made it just enough to make a hole. So I went, bugger. Anyway, I've fixed that with some aluminium welding rod, which worked out quite well. I've got it all nice and fixed. Now it's running with R152A. It's getting cold. There is, yeah, I didn't bother pulling a vacuum in this because it has still a bit of positive pressure in it when I put this on and when I welded that. Now you're supposed to purge nitrogen through it and you know gas, but there was plenty of flux in here anyway, and the aluminium bonded, so it was good. It's best practice to purge inert gas through the system when you're doing repairs to the line work. It's not good practice to have you know, your refrigerant, still residual refrigerant, percolating out of the oil and coming out of that, because it's not good to burn refrigerant. It's not good for you. But yeah, but it worked out alright. I didn't damage or oxidise the internals of the aluminium there. Cold there, frost there, frosty there. It's cold there. We'll see what the frost line does. My hand's sticking to that. One thing I really like about these earlier fridges, the condenser is outside. The new junk you buy nowadays, the condenser goes around here, around the back, and folds internally inside the cabinet. It's a pretty cheap, nasty design, because if you did develop a leak, especially because of all aluminium pipework nowadays, you develop a leak, you're screwed. You can't fix it. I see some of this 5/16 over the smaller diameter. I think it was this size. I think it was 3/8. I slipped over the top of that and welded it so I could put my line tap on it. I had a line tap on a spare compressor, and I've used that. I had this Tecumseh compressor with a line bullet piercing valve on it, and used that because I've run out of solderable ones, these Schraders. So I just put that on there. Now, yeah, there was definitely no negative pressure in the system, so it's completely fine to do it this way. A bit lukewarm coming back to the compressor. I didn't weigh in the charge or anything. I didn't weigh the charge in or anything. I just literally hooked this up, purged it, checked for leaks. I purged out of the hoses first, checked for leaks, and just let this freaking cut sit till it equalised at about 40 psi, and stopped going shh. Very quick and dirty, but yeah, it works. But the main thing is no air in the system. This will remove it anyway, but you don't want air in the system at all anyway, because air will cause damage. You're lucky it didn't, because inside here, the capillary goes inside there, crimps in here, and your suction goes around outside that. The capillaries in there. Your suction stops about here. It's sealed there, and the capillary goes through there. It's welded shut there and comes out here, where the capillary ends here. In here, back is suction, so it goes back into the suction. This is what's called a cold plate design. You can set a frost line, frost it to about here. It's a pretty good estimate, the amount of R152A I put in there. It's only had a very small charge of R12 in it. I tried my hardest not to nick the line, but my bloody Sawzall slipped. So, because I really wanted to preserve it as it was, but mistakes happen. Lucky it was only a small compromise in the system. It wasn't bugger all freaking, it was about, let's see, not 90 grams of R12, which I probably put about 100 grams of R152A in there. There would have been small amounts of R12 in the bubble in the oil of that compressor. Like when you open a bottle of lemonade for the first time, it goes shh, and you see bubbles in it. Well, that's what's happening inside there in the refrigerant oil. There'll be just a small amount of R12 just sitting in there, fizzing up. But you can mix that with R152A, it's blendable. And it doesn't damage or harm the oil, it'll be fine. This, as I said, this refrigerant's been around for decades, and they used to mix this with, I think it was mixed with other gases to make certain blends, and something similar to R114 and things like that. So it's compatible. As long as the gases are compatible with each other, it's fine. Otherwise, I would have had to pull a vacuum and get everything to bubble out of the oil as possible. The thermostat goes to the brown and the black, which I'll hook that back up later. Man, that's what's called a cold plate. It's a pretty unique design, a cold plate. Cheap and easy. You can get commercial features as one of these cold plates in it. That's frosty. Working quite well. I probably haven't got quite enough in there actually. The frost stops about here, so I probably need a bit more to get to here, and then stop the liquid about here before it goes back into the suction. I'm pretty bloody close for a guess. The heat rejection's all throughout the whole coil. That's rejecting heat nicely. It's quite fun playing with refrigeration once you it's an interesting concept. You definitely can't pull a new fridge apart intact like this, because the condenser is inside the shelf and inside the shell of the fridge itself. I'm going to make up some sort of a stand for this and make something so you can have that cold plate in an old chest freezer. You put the pipe work through there, sit it over the side, close the lid of the esky, and you can make the esky cold. And I'll hook up the thermostat in there too. But quite an interesting compressor. I don't know what that bolt's for. Must have been just a bolt, an optional, you can bolt or clip a defrost tray to it. Now later on in the years I used silicone and stuck it on the top. But this doesn't seem to be leaking. There we go, Goenji PW 4.5 kg. Tutovo Velenge, 220 volt, 50 hertz, R12, made in Yugoslavia, country that's now known as Croatia. It's quite a nice shape for a compressor because it's a lot more room in there, but the newer ones, the Chinese, heaps of junk. The shell is just one common size, and the whole modern compressors look the same now, and the shell is so tight around the mechanics, one little tiny hit, tap, and it'll rattle. They probably did that intentionally to make so you can put minimal gas in the system, save the environment, even though the new gases are R600A isobutane anyway, which isn't toxic, but if you burn it, you get carbon monoxide, just like burning propane. Yeah, I reckon a bit more R152A in there. Yeah, the frost line stops about here and it disappears. That's working quite well. Been running for about 20 minutes now. Nice. Yeah, the piston's got a lot of pressure behind it. I've got to be careful now. We're going to have to make something to hold this together. I might even make the little pocket around it to run water over it. Just have a water chiller or something like that. But this aluminium rod worked out quite well. Oh, we didn't put paint on that side. Whoops. What? I'm trying to find where I put them now. There were some cheap Chinese ones I bought at eBay, but they were junk. There was a bit of a gimmicky ad I said on Facebook. It seemed really gimmicky, and these are Australian made, so I sort of buggered it. I got nothing to lose, and these were cheap, so I grabbed some of these ones. It's flux cord solder, but aluminium, and it actually worked quite well. Fixing up, say if this had a hole punched through it, that'd be a very difficult repair, because all that is going to act as a heat sink, and this won't work. But that was a very small localised area, and it worked quite well. That was my very first successful aluminium repair using brazing rod. actually quite happy with that. I was going to just friggin' redneck JB welder, but not recommended. I was going to put higher chill in the system, but I'll just stick to R152A since it's more commonly accessible and cheap. Anyway, working quite well. I'm happy with that. Thanks for watching. Just gonna, as I said, set this up somewhere nice and neat so I don't damage and kink all the pipe work now. The basic workings of a fridge in a skeleton. It's something you can't do with new fridges, as I said. Anyway, thanks for watching.